Now this right here, where we're looking at printing out our values, it looks a little bit awkward because here it looks like we're dealing with a 2D array. And I guess in some sense we are, but there's maybe a cleaner way that we can do this by using something called an iterator. So I'm going to comment this out, and we're going to look at another way that we can write this same for loop. And this approach is used in many of the data structures that we're going to go over. The vector class is the only one that's going to allow us to use the bracket operator. So we're going to create an iterator, which is it's almost like a nested class. So we're going to create a vector int : iterator. We can call it whatever we want. I'll usually call it iter or it, and we're going to set that to our vector dot begin. Okay, so begin is a method that is going to essentially give us the starting address of our vector. And then we're going to continue to loop until we get to the end of our vector. And this end method is going to return the first invalid address. So let's say our vector is just 2 elements and it starts at address 100. Then we would go 100 through 103 would be the first 4 bytes for our integer, right? And then 104 through 107 would be the second integer. So therefore 108 would be the first address that's out of bounds, right? So that's what end is going to give us. It's going to give us the first address that's out of bounds. And then it can be incremented using ++, either side prefix or postfix. I tend to use prefix when I'm doing for loops because it's a little bit more optimized. So now we're going to go ahead and print out our value. So an iterator by itself gives you the memory address of your data. So, you know, when I set my iterator to point to the beginning of the array, that's going to point, or the beginning of the vector rather, that's going to point to that starting address of that array that the vector is holding. So I need to dereference it to get to the value that is there. Okay, so now I don't have to do this kind of 2D array type of indexing. All right, we should get the same output here. All right, so we're printing out all of our values. You can go back and double check and make sure that they're the same, but I promise you they are. And there we go. So we can go either approach here, right? We can use the bracket operator to index into things, or we can use an iterator. Now, the iterator approach is going to be better in some circumstances, especially when we get to potentially removing or inserting data into our vector, which is what we're going to go over next. Now that we have all of the values from our vector loading up and working with binary file input, which we could test out some of these other files real quick. So if we want, I believe I have one with a grouping of 5. So all I'll do is change this to the different file. It's going to have a different header, and we can see when we run this that we get groupings of 5 rather than groupings of 2. Right? So all I have to do is change the file. I didn't have to change any of my other code because I was able to read that file header. Right? We could do the same thing with our groupings of 10. and we can see that we have 10 per row now. Okay, so I want to remove some of these values, and I don't just want to arbitrarily remove some, so maybe I want to write a little function that lets me know which ones I want to remove. So I want to remove everything that's not a prime number, let's say. So let's jump up to the top here, and let's create a method, or a function rather, to determine if a number is prime or not. To check to see if a number is prime, and it will return true if prime. Okay, so we're going to just create a little Boolean function here that's going to take in a value and determine if our number is prime or not. So we can say if our value is less than or equal to 2, then we'll return true, right? Or I guess we could say return prime, because that is true as well. Okay. Otherwise, we need to start looping to see if it's divisible, right, by anything other than 1 in itself. So we'll start out at 2. And we only need to loop through half of the value, right? So we don't need to go through the whole thing. And if our value modded with I is equal to 0, then that means that we did not get a remainder, and therefore we're not prime. And we can go ahead and break out of our loop. Then at the end, we can return prime. And I forgot a closing curly brace on my if there, so this can come back. Okay, so this little algorithm here should determine if our number is prime or not. Let's go ahead and test that out before we start working with the file. So we're going to come down here and turn this code off. And I guess up at the top of the file, close to the top here, we can test if our number is prime or not. Right. Testing is prime. So let's just go through, say the first 100 numbers here, 1 to 100, and print out if is prime of I, then print out I followed by a space. Okay, so we got missing a curly brace somewhere. Not there. Where is my missing curly brace at? Good question. Oh, it's at the end of this guy. All right. So run this. That looks like all of the prime numbers from 1 to 100 to me. So I think we're good there, right? Always trying to do small tests when you can to make sure that your code is working properly. All right, so we can go ahead and turn this off now. We'll leave it there just in case. And let's come down to our larger example. Bring that code back on by turning that if to a 1, or actually it should be this one down here with our binary. Right? And now I want to remove some of those files, or some of those values rather. So before I print out the values, I want to remove some of them. Okay, so remove the non-prime values, which is probably going to be most of them, right? So I need to go through each vector, right? So I equals 0, I less than numvex. That's what we have to represent the number of vectors. And I want to remove everything. Okay, so we have a method, well, not remove everything, but remove all of the non-prime numbers. So we have a method that can do that within a vector, so within all the values sub I, which is a single vector, we have an erase function, all right? And it takes in an iterator, right, of where to erase from, okay? And we can, there's a couple of overloads of this method. We'll look at the documentation for some of those in a little bit, but we need to kind of understand how iterators work. So let's go ahead and create an iterator. So again, it's vector int iterator. We'll call it iter again. And we're going to set it equal to the beginning of this particular vector. And then we're going to loop through the vector and remove the non-primes. Okay. Now we might think, and we can go ahead and try this, right? So for int I equals, or actually we can use for nothing, right? Because we've already declared this iterator up here, right? Iter not equal to all the values sub I dot end plus plus iter, and we could say, hey, if r is prime of iter. Right, so again, remember an iterator is a pointer. It's pointing to whatever value we're currently at or whatever index we're currently at. So we have to dereference that. So if that's equal to false, then we can say all the values sub I dot erase and erase iter. All right, and let's see what happens here. Okay, so we're going to go ahead and run this, and our program is going to crash. Okay, so we're not doing something right here. It threw us into the vector class, right? And obviously there's nothing wrong with this code, right? We can see it says something about can increment the vector iterator past the end. When we experience a crash and it brings us into some code that's not ours, we need to use the call stack to determine where our code was initiating the problem. So all we need to do is step through this call stack here and find code that we wrote. Okay, so here's the line of code that's actually causing the crash. It's this call to end because I'm trying to, or actually, I'm sorry, it's this here because it's trying to increment past the end of the vector because of the way that we're doing the erase is incorrect. Okay, so let's look at a way to solve that. So the reason that this is crashing, again, is because we're going past the end of the iterator. The way that erase works is it removes that element and the erase function returns an iterator. Okay, so it returns basically the next index that would be there, right? So we end up kind of getting ourselves all screwed up over where the iterator is at. So a more appropriate way to do this erase would be with a while loop. So we're going to change it. Actually, we'll leave this code here for a comparison. So we'll comment that out. bring it down here, make a little comment that says bad. And let's do a while loop here. So while our iterator is not equal to the end of our vector, we want to check this to see if we're prime, just like we did before. If we are prime, we want to remove that value, right? So we can do all the values sub I dot erase, just like we did before, pass it to iterator, but we're going to set our iterator to the value or to the new iterator that erase returns. So to give you an example here, right, if we had something like 2, 3, 4 in our vector, right, then actually all of these are prime, right? Well, actually this one's not prime. So when I erase 2, my iterator is going to automatically point to the 3. That's what erase returns. So we return an iterator to 3. So I wouldn't, with this for loop example here, I would then be incrementing, right? And I would never be testing against the 3. So then it would skip over to the 4, right? So what I want to do is set my iterator to the new iterator after the erase happens. And if I did not erase, right, we're no longer in a for loop, so I need to have that increment there, right? So be like similar to this plus plus here. Okay, well, let's give this a shot. Hopefully this works. So now we've removed everything that is not prime, right? We could, you can verify this if you need to, right? But it looks like we've removed quite a few of the values, right? And these blank lines here, that would have meant that all 10 of the values were not prime, right? So don't see anything in here that's jumping out to me as being a non-prime, right? At least everything's ending with an odd number. You can go through and double check some of these if you want to determine if they're prime or not. Okay. So the last thing that I want to go over is documentation for the vector class, and really for any code that you're using, any of the built-in stuff.